Welcome to the Thermochemistry and Reaction Rates crash course. On your semester exam for these two topics, there are approximately 15 questions because it is considered two separate topics, thermochemistry and reaction rates. The only math required for this section, there are three different things. That would be energy conversions, converting between joules and kilojoules and calories, remembering that you will be given the conversion factor that says 1 calorie equals 4.184 joules. However, you should be able to convert between joules and kilojoules on your own. And you'll also have the Q equals mc delta T equation. This equation is going to be for temperature changes only. So this is the equation that you use to figure out the energy that was needed to change the temperature of a substance without going through a phase change, or you can also use it to figure out the specific heat of a substance if they give you the energy change. So the units here, we've got heat or energy, which is usually joules. This is mass, that's specific heat, and this is change in temperature. Then the other equation that will be given to you is the Q equals N delta H equation. And this is what you will use to calculate the energy for phase changes only. So these would be questions like how much energy would it take to boil 10 grams of water, or to condense 10 grams of steam, or to melt 10 grams of ice. Right? It's all about the phase change. And the key here is you have to remember that your amount does have to be in moles, even though you're often given grams. And the reason why it has to be in moles is because your delta H unit is in kilojoules per mole. Right? So you need those moles to cancel to do this calculation. You will be given the delta H's on your formula sheet, the enthalpy of fusion and vaporization, which are both endothermic phase changes. To do the other phase changes for freezing or condensation, you just make them negative, if you remember that. Beyond that, there is no multi-part questions. So if you remember earlier in the year, we had done questions where you had to use this equation twice and that equation once and add it all together. There will be none of those on your semester exam. They will be simple, one step, just a temperature change or only a phase change, and that is it. So those will be the calculations. Beyond that, there is a fair amount of vocabulary to make sure you understand in this unit if you're looking over the semester exam review. Things like endothermic and exothermic, understanding what those mean, how they would feel if you were holding on to containers that were endothermic and exothermic, as well as specific heat, those types of things for this unit. System surroundings, all of that stuff. Also with thermochemistry, you will see the heating curve again, right? The heating curve that had the different phase changes and the temperature changes. We also saw this earlier in the states of matter unit and repeated it again briefly here in this unit. So make sure you review the heating curve and how that relates to energy changes. Okay? So that's the thermochemistry portion. Then you also have the reaction rate portion. And in reaction rate, right, a couple of things that we covered. Collision theory, right, understanding the requirements of a collision in order for a chemical reaction to occur, as well as the factors affecting reaction rates. Right, factors affecting reaction rates was in this section as well. And lastly, in this section, you had your potential energy diagrams, which your exam review does ask you to sketch, understanding what activation energy is on those diagrams, where the reactants, the products, the activated complex, all of that good stuff. And that should be sufficient for understanding potential energy diagrams. Okay. So that concludes the crash course on thermochemistry and reaction rates. Again, please refer to your exam review for specific questions and examples, and let me know if you have any questions.